Hey buddy, welcome to the channel. In this video, I am going to show you how I built a complete machine learning model which predicts whether the water is safe to drink or not. The video covers complete steps to build a machine learning model from data importing, data understanding, visualization, pre-processing, selecting a correct algorithm to build the model, training and testing the data, and checking the metrics of the algorithm means checking how accurately the model predicts the output. So the one video covers almost complete machine learning model building. So the only part remains that we use different algorithms to train the models. So I have covered almost three algorithms in this video. You can learn different algorithms by yourself easily. So each step I have explained in easiest way. So even if you are beginner, you can easily learn that. So I will show you two examples. The first one is, as I said, water potability. The machine learning model predicts whether the water is safe to drink or not. In this, I I trained the model twice with different data, and one model predicts the output with almost 99% accuracy, and one still stuck at 67% accuracy. And I have built another one model that is car selling price prediction, that also predicts the outputs with 99% accuracy. So in this video, we are going to see what are the reasons that two models are predicting the output with 99% accuracy and the one is still stucking at 67%. So stay tuned and let's start.
So these are the steps required to build any machine learning model. I am going to explain each step in simplest form so that even if you are beginner, by following these steps you can build any machine learning model you want according to your data, your requirement. So the steps are same for building any model, that you have to understand data, that you have to clean the data, visualization, data splitting, pre-processing, choosing the algorithm, model evaluation. These are the fixed steps. The only part changes that choosing the algorithm. In this video I have used logistic regression, random forest, and gradient boosting. You can use any algorithm according to your data and your requirement. So let's start with the example of water potability prediction. So in this example, we predict whether the water is safe to drink or not. Let's start with the first step. I have imported Pandas, a Python library for easily handling the series datasets, and I have imported Pandas as PD. So by using PD, I can use the whole functionalities of Pandas. So I have imported the I have read the CSV file. I have imported using from here sample data upload and upload your CSV file. This water potability CSV file I have used. So these complete content, complete data set of the water CSV file we get into the variable df. So this is variable, you can name anything you want like data, etc., anything. So this is the next function, df.shape. Shape gives the size of dataset. It means number of columns and number of rows. So our dataset contains 3276 rows and 10 columns. Next is df.head. Here you can pass any number, 8, 3, 5. By default I have not passed any number, so it will give me 5 rows of each column. This gives us overview of the dataset. So these are our 10 columns and the values are present like this. So the next is null and dot sum. So is null dot sum gives the number of number of missing values in each column. Like pH contains 491 missing values. The sulfate contains 781 missing values. Trihalomethane Trihalomethane contains 162 missing values. So I have talked about that this model stuck at 67%. This is one of the major reason why the model stuck that 67% accuracy, because it contains too many missing values. So the next is DF dot portability. Now portability is the output. This we have to predict. So we will understand whether this portable how the values of portability are present in our data, whether it is biased or not. So let's see, the zero means non-potable, means the water is not safe to drink. Those values are almost around 2000. And potable values means the uh, values are around 1200. So the our data set is biased towards this non-potability. This is another reason why the accuracy stuck at 67%. So everything depends upon the dataset and how we pre-process the data. So as we have seen that there are so many null values present in this data, we need to pre-process them or fill the null values. There are so many different types to different methods to fill the values. In this example, I am using mean of each column to fill these null values. So this means fill in a df dot mean means it will calculate the mean of each column and fill those null values with that mean of that column and updates the database again. We know that the pH factor in the dataset of water potability is the most important factor. So what we will do, we will draw the histogram to see in which range the major values lies of the pH column. And the next one is the output that we have to predict. So we will see the bar graph that how many zeros and how many ones will be. Zero means, as I said, that the water is not safe to drink, and the one means water is safe to drink. So we can see there is major difference. So the database is the biased one towards the non-potability. And as we can see in the histogram that the major values lies between the 6 to 7 values. So these codes means the same that in this video we are plotting the histogram for the pH value and bar graph for the potability using the matplotlib library used to draw the charts, means plotting the graphs. Just like we've seen before that we have 10 columns in our dataset. So what we have to do is we have to pass the input, and based on the input the model will predict the output. So the output is the potability column. We have to predict the water is potable or not. So we will in input we will just drop the potability column, and the remaining 9 columns will act as the input feature. So in y we will just give the portability column, that is our output which we have to predict. And in next step we will split the data into training and testing model, uh, testing size. So we will give 20% of data, means this 0.2 20% of data for the testing purpose, and the 80% of data for the training purpose. We will first train the model based on that 80% data, and the remaining 20% data we will use that for testing our model, the accuracy. And the random state we give 42. So this is the standard number used by many machine learning developers. We can change this if we are getting less accuracy. By changing this we can slightly improve the accuracy. So the random state function ensures that the equal split of data in every iteration. The next step is pre-processing of the data. So we will see why the pre-processing is important. As you can see, the solids column have the values ranging in 20,000 and the pH has values ranging to 7, 8, but it means 1 to 14. So if we didn't pre-process, the model will think that these big values are important for the prediction and the small values are not. But in reality, we know this is not the case. So that's why we pre-process the data using standard scaler. So what the standard scaler does is it uses the formula of x minus x mean upon sigma, and the sigma has the another formula that root of summation of x minus x the whole square divided by. So that is the statistics part. But what I have to tell that the it makes the all values in same range, so that model does, doesn't bias in these columns that the values with big numbers are important and smaller are not. So all values comes in equal range. That's why we pre-process it using the standard scalar function. The next step is choosing the perfect algorithm for your building the machine learning model. The choice of algorithm depends on the data set. So in this model, I have used three algorithms, that is logistic regression, random forest classifier, and gradient boosting. So the steps are same for any algorithm you use. Just the thing changes here where you import whichever algorithm you want to use according to the dataset. So if you follow these steps and understand, then you can build any machine learning model. So let's see what are these algorithms. First one is logistic regression. So what logistic regression does is it is a simple basic linear classification algorithm which classifies the values based on the line. It makes the line and one side of another is one group and other side is classified into another group. The next one is a random forest classifier. What it does is we we s- we divide the data set into many different parts, and each part is given to the each decision tree, and it predicts the value. This random forest classifier is the cluster of many decision trees, and they predict the values, and we choose maximum among them. We choose maximum opinion, maximum prediction of them, whether they maximum have predicted water is safe to drink or not. Let's consider with a simple example. If you don't understand this, suppose we are asking 100 people that the water is safe to drink or not, and the people gives their opinion, and we choose maximum opinion among them. So the next one is gradient boosting classifier. So in this, what happened is that in random forest we ask random people, but in uh, gradient boosting classifier we ask people independently about their opinion, and the one tells their opinion, and next one understand his opinion and reasons pros and cons. Then he gives his own. Same thing happens again. He gives his opinion, and the other person understand that, and the next person gives opinion based on previous reasons. So the accuracy keeps on increasing. This is different between random forest and class gradient boosting classifier. This gives this here we ask randomly to all people, and here we ask one by one, so it increases the accuracy. The next one is accuracy score. We import this for checking the accuracy of our model. and the next one is classification report. So classification report is a table that tells how good our model is. So in model variable, we are getting the name name of the algorithm we used and the actual algorithm, the function. Same for this with the random state 42. As we said, this is standard number. You can use any, but I prefer using this, or I suggest you to use this. So the next we use for loop for the for testing each algorithm. For name, that is logistic regression, and the model, that is this logistic regression function in models.items. So we are first fitting the training data into the model, model.fit x and y, and then we are predicting by giving the testing data. So next we print the name of the algorithm, then the accuracy. Using the accuracy score which we have imported here, we give y test and prediction into 100. So this gives the accuracy. The logistic regression gives the accuracy of 62 to 62%. The reasons I have explained earlier why this is very low. The next is classification report. Now classification report is a table like this which shows the how overall good our model is. It includes terms like precision, recall, F1 score, support. Now if I explain all these terms, the video will become much lengthy. I will show you some short notes. Read here or take screenshot of this. You can understand easily. These might be new terms for you, but while you read once, you can understand. So accuracy is this: recall, precision, F1 score, support, and this is the example that we taken from this water potability dataset. So the accuracy of logistic regression is 62%, accuracy of random forest is 67%, and accuracy of gradient boosting is 65%. So I considered the accuracy of the random forest, which is the maximum, as 67.85%. So this was the all the steps that were required to build any model in the machine learning. The only part changes that choosing the algorithm. And let me show you the another model I built for water analysis with different dataset. I take this dataset from Kaggle and build the same model. So the this dataset wasn't biased. So and there were minimum null values present. So this model gives the accuracy of 99%, 99.99%, means almost 100%. So the accuracy of model depends on how the data set is good, and how you can make it better, how you can pre-process it, how you handle null values, etc, etc. So everything depends on the data set. And let me show you another project, that is car selling price prediction. I have built the model to predict the car prices using all the steps that I have explained for water portability. So all the steps are same. If you understand the steps, you can build any model. So the dataset for this I take from Kaggle, and the accuracy of this model is almost 83%. So I hope you have understood the how to build model, machine learning model for any purpose. Just remember the steps, and I hope you have understand the steps. If you have understand, then please comment what you think about this video. Was it helpful or not? What changes I could have made to make the future videos better? And thanks for watching. Bye. Have a good day.